Hi, it's Ray from ProShaper in Charlton, and this is part 6 of building the E-Type all aluminum nose, the complete bonnet. This is just the front section. It was been covered in parts 1 to part 5. Part 5 was A and B. You got to watch the whole series to get the whole flavor of everything. So what we're doing now is I did this side, which is the right side. This is the left side. I didn't do that on camera because it's just a repeat of what we did over here on this side. So now I've got them all trimmed, basically all from the flexible shape pattern. The flexible shape pattern tells me exactly where these panels have to join and the actual joint itself. So I got it clamped up. I put a little copper under here so that it'll give me a wider contact for the clamps. I've got right here, this is a red index line which came from the flexible shape pattern. That's dead straight. That's all lined up perfectly. And the joint is nice and tight. Generally I always start in the middle of a panel when I'm welding them together. I'm going to do some tacks. We're going to be TIG welding this. We will do some gas welding on some of the other joins that we have to do, but this is all going to be TIG. And I'll put a bunch of spots in here to tack it up first. And it's very difficult to clamp the piece together because it wants to collapse this way, and that changes the whole joint measurements and everything. And you got a little bit of a gap here, and I got a little bit of a gap here, but as I work from the middle out, those gaps close in. That's a general rule of thumb on every welding job. So if they close in too tight, I'll stop and I'll hammer them. But I'm just going to put light tacks. If your joint is tight enough, you can put a fusion tack, but this one I'll probably add a little rod. We're going to weld both sides of it. The content of this video is just joining these two pieces. It's not really a video on TIG welding or welding in general, but there'll be a lot of welding going on during the video. I will do a specific TIG welding versus gas welding video at some point in the future, and I'll try to cover everything in that. But this one is just to get these two pieces together. And this is like the trophy piece of that Jaguar bonnet. This is the most difficult piece, the front top piece. The bottom piece is no piece of cake either, so that's going to be pretty difficult. Once I get those done, the difficulty factor drops down quite a bit. So I'm going to do the bottom piece later. Next, after we finish this one, we hope to get this all welded together tonight and metal finished. I might not metal finish the whole thing, just partially, and just in an effort to keep the video a little shorter. After that, then over the hoods over here, the center section we're making, we're going to make the center of the center section, the forward center part of it. So right now we've got this all clamped up. It's not clamped up perfect, but as I said, as we weld it, it'll come together on its own. And once we get 3 or 4 tacks in here, this will start to have some stability. Now what I prefer is I exclusively use wire forms in most of my projects here. And if you have a wire form for this, you can have the wire down the center, but then you would make the joint about a 1-inch distance from the wire, which allows the panel to be relaxed, setting on the wire form. You can get the clamps in there. There's no pressure for the panel to move around or anything. You clamp it up really nicely, and you can put your tacks in, take it off the wire form after it's tacked, and then totally weld it up. But here we have to, it's a wrestling match to get this thing so that it stays together, because it just wants to open up this way, and when it goes down this way, gravity is pulling it, the joint opens up here and it opens up here. But we know it's indexed because we have this red index line, and it's a straight line, and it's all showing good. So we're going to start with the first tack right in the middle, right here. We'll do 2 or 3 tacks maybe in that little window, and then we will move the clamps out. So I'm using 1100 rod, and this is 3003 material. I've got an Everlast machine I really like it. It works really nicely. It's the 210 EXT, I believe. We're using, this is a real key ingredient, is we used to use argon exclusively for aluminum, but this is a 50-50 argon helium mix now, which makes a major difference. When you add that 50% helium, which is a little more money, for the lens I'm using, I believe it's a number 9, maybe it might be a 10 lens for the TIG welding, and I use a 2.5 magnifier inside my helmet. I got it taped inside there. I don't like the automatic helmets. I like the old style helmet. For the tungsten, I use a 2% lanthanated tungsten. It has a grind back, a taper on a standard bench grinder about 1/4 inch or so, and it'll self-form a really small ball. If you use, I used to use the 2% thoriated, on aluminum and steel and everything, and once in a while that 2% thoriated tungsten will, the ball will kind of migrate. There'll be two balls there, and you got to break one off sometimes, and it's just crazy. The lanthanated is much more stable. It forms a little small tiny ball. You get a beautiful intense heat coming out of it. Highly recommend that lanthanated tungsten. That's the blue. The lanthanated is the blue. All right, so we're going to do the first tacks now. I got one in there. And those are a couple of fusion tacks. And I'm using a gas lens also, which is a nice advantage to be able to use that gas lens. You might be able to fusion tack these too, because that'll come in right nice and tight now. Now the very important thing is when you're welding either steel or aluminum sheet, you always want to make sure that the sheets are level. If you're off just a little bit, it can be a problem. So it's best to, that's why I like to clamp it up really good. So I've got a bunch of tacks there, and I'm going to continue on this way. I'm doing fusions now because the joint is really tight. As long as it's really tight, the fusions are pretty easy to do. You have the rod in reserve. I'll take this one off. So a perfect, nice level joint. And then sometimes you get situations like that where it's just hard to get. It doesn't want to cooperate. And we'll put a regular vice grip right on the end here. Get one more tack in there. With each one of these tacks, the stability of the panel gets much better. So we're almost there now. It's just coming around the horn. This is where the greatest amount of strength is, right on this front radius edge. Alright, so we have the two panels all tacked up together now. We did really closely spaced tacking. A lot of it was fusion tacking. These tacks have no strength whatsoever, but they do have enough strength just to hold the panel together. Now the real important thing is to keep them level, and they're very good on the level part of it here. We're also lined up with our index line. It's nice and straight. It's at the same point. That's super important. So what we want to do now is we can do a continuous weld, and with TIG, to be safe, it's a good idea to weld the top side and then run the weld on the back side. You can do a one-side TIG weld and have a pretty decent weld, but it requires a little bit of luck to do that and a lot of expertise. By no means, I've been TIG welding for years and years and years, but by no means am I an incredible, perfect TIG welder. Most of my TIG welds are all ground away and they disappear. You don't see them, so I'm not welding motorcycle frames where I'm doing all that, you know, stack of dimes and the walking the cup and all that stuff. There's guys that can do that, you know, hundreds of times better than I can. That's not in my domain of what I do. I just want a good sound weld. I can gas weld this, and like I said, some of the we do a welding video. We'll also cover gas welding. I think I covered a lot of the good points on here. We're going to get a little bit of distortion, but we're going to grind this and hammer it on the planishing hammer. And I don't think we're going to show the finished weld. We'll do just a little section, show a little finished part of it, because we're going to run out of time on this video. We're trying to make it a little shorter. So first thing I'm going to do is just run the top here, and I'll continuous weld this, and then I'll weld the bottom. Now, I had a student from the Netherlands who had a technique of welding the bottom first. He didn't even tack it, he would just weld it. But that was on flat coupons. I don't know how well that works on a shaped pot like this. And I guess this is probably your first view of the panel, all made from flexible shape patterns. And you know, it's a really beautiful panel. It's shined up really nice. That's all from the wheel. There's no grinding or anything. All the edging was done with a hammer and dolly and a tipping wheel. I did make a form for this, and I did use the form to double check it. There was a few spots that I wasn't exactly 100% correct, but you can do it without the form. And after I did it with the form, I checked, in the form actually had a different radius on this side versus this side. This one was a sharper radius, this was a duller radius, and it looks like there's probably a little bit of accident damage actually in that hood. So I can enhance those and get them a little bit better. It's almost perfect now, but I'm crazy about trying to make it look as good as it possibly can. So we have a engineered joint here from the flexible shape patterns. We've welded it together, and now the next step is this assembly is going to weld to a bigger assembly, and we're going to find where this line is. The line's there, but we'll put the flexible shape patterns on again. We'll make a blue tape line, first a magic marker, then idealize the line with a blue tape, and then this will weld to the assemblies that are further on back on the bonnet. That'll be later on. Like I said, this is number 6, dealing with joining these two panels together. Also, in number 6, we're going to do this little bit of a weld here. When these corners come together, they get welded right here. So we'll cover that. And we'll clean this weld up a little bit. And but that's as far. I don't think we're going to finish it tonight. I'll do the rest of it off camera. And you've seen a lot of the professional coach builders. They'll put tape on either side of your weld, so that kind of holds the cleanup into a little confined strip, and it looks really cool. It really has no big picture significance, because eventually this is all going to be sanded with an orbital sander and painted unless you're running the panels bare. So part 7 will be making that center section of the bonnet. and that'll be a whole new deal, making that center section. Not as complex as this, but still it's got a good difficulty factor to it. So let me run the weld on this now. Now welding, whether you're gas welding or TIG welding, you want to try to get as comfortable as possible. So I'm going to put this panel down and see if I can get comfortable. So I'm going to put it like that, and I'm going to weld it across like this. I'm going to feed rod in it. I'm not going to do a fusion weld. I generally don't like fusion welds. I've done quite a few of them. It's all right for the tacks here, but when you do fusion welds, inevitably you're going to get a situation where you have a little divot that needs to be filled. So if you add a little rod, that's a good thing. Now, TIG welding gets a bad rap for having the potential to crack. And it's my opinion that any cracking in a TIG weld is caused by there wasn't sufficient heat induced into the area to make what I call the handshake. That's when one side joins with the other. You have to have a certain amount of heat. Now that doesn't necessarily mean your amperage being turned up. It might mean, well, it can be amperage, but it also could mean the amount of dwell time that you're on the weld. So if you take your time and let the heat build up, actually with lower amperage, I'll probably run like 50 amps. I got 51 amps, that should do it. And I'll try to go a little slower, and I should get a pretty nice bead. Now I'm going to grind it, and like I said, I'll probably only grind a little section here, and then we'll finish that out the way it's supposed to be, because it's going to take too long to show it all on camera. My hose hung up. I touched the tungsten. Sometimes, nope, that one got loaded, so I'm going to have to stop and grind the tungsten. Okay, so now what we have here, this is the underside. As a safe bet, it's a good idea to run the weld on the back side. You don't have to add any rod. You just bring the tungsten over and let it roll. So, problem is the pot's always catching you on the hose or something. Now you saw I hit the puddle a couple times, and generally on a TIG you can hit the puddle a little bit, but if you hit it a lot it's going to wick up on the tungsten and you got to stop. But you can get away with a little bit. So now I got to turn the panel around and we're going to run it this way now. And there we have it. The weld is on both sides. Now this weld should be very, very good. You can actually torture a weld like this, meaning grind it and hit it with a ball-peen hammer, and you can raise about an inch blister with a ball-peen hammer before that weld will start to not break, but it'll break adjacent to the weld. Now, if you do that, sometimes during the class I show that demonstration, and you'll get a fracture in the weld. Whenever you get a fracture, when you're really torture testing it like that, it's not because you didn't do anything other than, I believe, you didn't get enough heat in the area. And all you have to do is, if you ever get a crack, is just re-weld over it and you won't have a problem. Now generally you don't have a cracking problem with gas unless you do a really horrible job. The reason being is gas really loads the panel up with a ton of heat. This is more of a concentrated heat. And the heat dissipates so fast because that's what aluminum does. So cracking is lack of heat more than anything else. Now cleanliness is played up really big. You're seeing me, I'm using a stainless brush here, but you know, there's all kinds of special cleaners and all these other things, and a lot of people obsess about the cleanliness, and I've found it's more the heat is the problem more than anything else. It's a wise policy to keep it as clean as possible. But as you see now, this is a really strong assembly. And it's a beautiful looking piece. There'll be a little bit of distortion here, but once we grind these welds down, we'll be able to planish that all out in the English wheel. And you probably have to do some hand work in here because you can't get the English wheel, or maybe even a planishing hammer die might get in there. If not, you can do it with a dolly and slapper. So we've got this much done. Now what we'll do is we'll go to another bench with a blanket on it, and we'll clean up this weld about 3 or 4 inches, and I'll show you what the finished weld will look like. I'm not going to do the entire weld on camera, so that's the next step. Alright, now we're all set up to do the grinding. We're going to do this little 4-inch stretch here. It looks like we're all positive here, meaning there's enough material, we're not going to have any divots. I use Norton 50 grit to knock this down first with. And start out with a 3-inch, and then they get a little bit smaller, and I can cut them down even some more. So I use an old pair of shears here, and learned this trick a long time ago at my grandfather's, that if you cut them uneven like this, it's these little tips that really grind like crazy. When you're grinding aluminum, it'll clog the wheel up a little bit, so I put a little wax. It's just standard candle wax. I got a bunch of it. So now, generally, I don't know if I've talked about this before in my videos, but generally everybody will grind across the weld like this, and the danger is when you do that, you can dig in on either side of it. You want to restrict the grinding as much as possible just to the weld bead. So you want to get really comfortable, and you want to be able to see it good. So I got it over here now, and I call it skating along the weld. Now it's a little bit uneven here too, and you can hammer it a little bit if you want. All right, so we're all set here. You're going to run the grinder at a moderate speed. You don't have to go full blast. You're just going to keep kissing that. And you watch where it's hitting the parent metal. Every time you grind, you check it with your finger. Alright, that's still a little positive, and you can see I've kept all the grinding to within a ½ strip here. And then we'll do the same thing on the bottom here. We got a nice bead on the bottom here. This bead also, you can see how beautiful that weld is. It's super clean, and that's because of the helium. If it was just straight argon, it generally isn't that clean. Now, once these tips get worn, then you got to replace it. They don't last too long. So, the problem here is biting in, so you got to be very careful. And sometimes it makes sense to turn the panel around and take in the another angle tack at it. Okay. So I bit the parent metal just a little bit, scratched it up, but I didn't remove any major material or anything. So I'm going from here to here, about a 4-inch swath. Now you can take and hammer this out. Now another thing is, on these TIG welds, you can anneal it. That's taking a acetylene torch, and you can soot it, or you can put magic marker on it. I believe the magic marker actually works a little better than the soot, because sometimes the soot can come on at different thicknesses. You put the magic marker on and just heat it enough to remove the magic marker. So I'm going to be doing this in the planishing hammer, but I just want to show you that you can do it with a hammer and dolly too. So if you did anneal this, it'll crunch down a little bit easier. And it might help with the potential for a crack or whatever, but I don't think we're going to get any cracking problem here. So you want to hear that contact. You really don't want to wheel on it. You're just going to do these little light planishes. So that's the way you would pound that in. But we're going to go over to the planishing hammer and just hit it in the planishing hammer. It makes a really nice job of it. All right, so I have a flat bottom die here, and we're just going to give it, let's set the hit rate. We got a nice little light hit rate here. And that can do a much nicer job than the slapper and the dolly. That said, you can do it very good with the slapper and dolly. It just takes a little longer. So we got our spot. It's still a little proud, so now I'm going to use a different grinding technique to get that. And we'll grind in here too with a different technique. That's next. So now I have a little hook and loop 2-inch soft pad, and these are actually some purchased 80 grit hook and loops. I think they were Keen abrasives, I believe, but most of the time I make them myself. I made a little punch and I make them. They're a little bit bigger. These are 120s. We'll use that in a minute. So just like the grinding disc, we'll put a little wax on here. Now when you rub the finger on here, you can feel the abrasive cut, but actually this little abrasive will only last a couple minutes, and then it loses its cutting ability on the outer edge. That's all we use is the outer edge. Then you can recut these down and use the smallest center section later if you want. So we're just going to blend this in now. So that blended that side. Now we turn it around like this, and we blend this side. And that's probably dead, so we'll get another one. Make sure you get a nice cut. These are pretty inexpensive. You get two turns out of it, you'll get the center section too. Now I'm feeling this is feeling really nice. So I got a nice blend there. I haven't put the tape on here, but you've seen I've restricted my grinding to a very small area. So that's the top. We can go on, let's do the finish to it. So we can take now, this is the little detail Harbor Freight orbital sander. And we'll put some 120. These are pads I've cut myself. Hook and loop. Hook and loop's the only way to go. I used to be a stick it guy, but now I'm strictly a hook and loop guy. Again, put a little wax on it. I love this little sander. A bunch of companies make them, I guess, but these are very inexpensive Harbor Freight, and they work great. So there's our 120 finish. We can go better if we want. And first we'll maybe do it with 320 or something. But let's do the underside again here. So the underside, we'll go back with another 80. Put a fresh 80 on here. Now, oftentimes the underside doesn't matter so much, but this being a tilt nose, and especially if you're leaving it bare aluminum, you'd want to see a nice weld seam there. So. If you're lucky and you finish it off nice, you can get this inside weld seam looking almost as nice. It's going to have a little undercut on either side of the weld, but it's not too bad looking. So we'll go to the 120 now. My wax always has a habit of hiding. I put it here and I'll find it underneath. I don't know why that happens. So I haven't dug into the parent metal. I probably took away maybe 1/1000 or maybe 2/1000. And it takes time to clean up these welds. Let's do a 320 on here. Let's see if I got a 320 disc. I had a 240 and I have a 400, so we'll just hit it just on the top side here with the 220 and the 400. And now the 400. That's perfectly smooth. If there's a problem, a little heat distortion or something, we'll get this in the wheel after and make it really perfect. But it looks like it's coming out good. There was a little scratch right here. It has nothing to do with the welding. I'll sand that out probably. So most of my panel came out with the nice super shine on it from the wheel. The wheel prints that shine on it. And I have this little strip that I'm doing the welding. Now I can put some tape while I'm doing all this, but maybe I'll put some tape later and I'll just Scotch Brite it and it makes it look very nice there. But I'm not going to finish this totally off on camera. I'm going to do it after. It's the same procedure, just takes more time and it's just filler. So, well, thanks for watching. It's Ray Schelin from ProShaper in Charlton, Massachusetts. Remember, I do teach classes. Check out my website, ProShaper.com. Keep the comments coming. Keep the questions coming. I answer all the questions. I have a cell phone. I hear it beep. I answer the question. So I appreciate all that feedback. And we're going to do a whole bunch of these really cool videos. And please share them to other forums, to your friends, anywhere you possibly can. Get your friends to subscribe. I'm trying to build the YouTube channel up. Thank you very much.